Well, hello, scrappers, chemistry enthusiasts, YouTubers with any sort of technical interest. Welcome back to my channel. Alright, today is going to be part 3 of me trying to make nitric acid from my mixed nitrate wastes. Mostly copper nitrate, but there's other stuff in there too. Now, in part 2, I had some success at this. I managed to make a little bit of acid, but I had some issues. I hope I've got the issues fixed. Now we're going to have pretty much the same setup as last time with a few minor changes to try and make the system a little more gas tight. I'm still setting up, but this is going to be the new suckback preventer, which I think will be a little more gas tight than the last one, which leaked like a sieve. Inside the fume hood we're going to have pretty much the same assembly as before, except I'm going to fill the graduated cylinder with hydrogen peroxide solution instead of distilled water, and hopefully that will work better for converting the nitrogen dioxide into nitric acid. I also found my stainless steel clips so I can put this together and not have to worry about the clips near the heat melting. So I've still got some setup to do. So let me get the camera on the tripod going, and I'll talk to you about some of the other changes I made while I'm doing some setup work. Okay, hopefully I can do this without blocking the camera too much. First off, I remembered to put a brick on my ring stand, so hopefully that's not going to heel over on me now, like before. It was a little top heavy. Someone in the comments suggested or said that it's better practice to be feeding the condenser from the bottom, and he's absolutely right. I did that by mistake last time. I noticed it was feeding from the top, but I was already filming and I decided to just run with it. So this time we're feeding from the bottom the condenser. Let's see. A lot of people told me, you need to go see Nerd Rage's videos on this. Okay. You know, believe it or not, I haven't seen every video on YouTube on making nitric acid production. But since so many people said I needed to go watch Nerd Rage's video, I did go watch Nerd Rage's video. And you know what? I think I may have seen it in the past, but I probably kind of tuned it out because he was making his own copper nitrate to start with to convert it to nitric acid. And I'm like, well, I don't need to make copper nitrate. I've got tons of it. I'm up to my eyeballs in it. I may have tuned out before I saw the rest of it. One thing I did get from his video, though, was he used Teflon tape to seal his ground glass joints. He said it's not a perfect solution, but none of the other solutions are perfect. So we're going to try the Teflon tape today and see how well that works. If it works, we'll find out. Probably going to work a little better anyway. So yeah, Teflon tape. I've already talked about the new suckback preventer over here. Just went with one of my big sidearm flasks, and I didn't have any stoppers that would fit them before, so I ordered a couple since the last time I tried this, and I got some better fitting hose, so hopefully this will be an airtight solution over here, hopefully, and we can convert all of the massive amount, well, some of the massive amounts of nitrogen dioxide this setup produces into nitric acid. So I also put some, you know, I talked about in the fume hood, I will put some hydrogen peroxide solution in the bubbling graduated cylinder in there. I'll also put a little in the bottom of this, but I'm also gonna collect the first water to come over from the distillation. And that will be a weak nitric acid, I'm sure, so I will dump that in here too. And then I will, once we're getting what looks like pretty strong nitric acid coming over, I will swap this beaker for that one back there, which, as you can see by the orange fumes in it, recently held some fuming nitric acid. So, and we will collect the nitric acid that's produced in that. So we should get nitric acid here, fairly strong. We should get nitric acid here, dilute, and we should get nitric acid in here. Again, dilute, but maybe we'll see. We'll see what the strength looks like. I don't know if I'll be able to calculate the strength all that easy, but we can try. We can try. That may actually you know, cross over into another video. That may be too much for one video. But I gotta get that ice down so it's cold, get some hydrogen peroxide in it. I've gotta get my cooler full of ice and water down here so that I can use that to cool the condenser over there. And I need to get my boiling flask in here, and I need to pack sand around it. And yeah, then we'll be pretty much ready to give this a try again and see what we can do. I gotta get kick clips on there too. Okay, I can get my thermometer in. Yeah. Maybe adjust this so it's a little more vertical. Okay, so let me finish setting up and we'll be back when we're ready to go. Gotta make one more change. I'll tell you about that in a few minutes. Okay, I think the apparatus is pretty much set up. A few more minor things to do before we start it up, but I'm ready to put the material, the crystals, in this bottle here, the blue crystals. I'm ready to put them into the boiling flask, but we're doing things a little differently this time. I said we were going to do one thing differently. I lied. We're going to do a couple things differently. First off, we're going to measure out the amount of crystals we're going to put in there, okay? Like I said in the last video, we're going to be a little bit more scientific about this. Now, a little more scientific, yeah, but I don't expect this to give, you know, absolutely reliable and reproducible results, because this material is a mixture of nitrates. It's got some sulfates in it. It's wet. And, you know, from one batch to another, even from the top of this jar to the bottom, the amount of moisture is going to be different. So I do not expect this to be an absolute repeatable experiment. This is going to sort of give me a ballpark number of what I can expect to get from this material. So do we want to do 100? Yeah, let's do 100. Yeah, 100 makes the math easy, but 200 will make a decent amount. Yeah, you see we're getting down into wetter stuff down here in the bottom. So, you know, the amount of water in this is going to vary a lot. You know, I crystallize this stuff by evaporation. Some salts may have evaporated out before other salts, so this may be stratified. So, you know, don't take this as gospel. I'm certainly not going to. See if we can get up to 200 here. Oh, I guess 200 is the limit of my scale. Alright, right there, 200. Alright, so we got 200 grams. Ugh, I gotta clean up this blue mess over here. Do that in a minute. Now we're going to do the other thing that I said we're going to do differently. Okay, in the last video I had a heck of a time getting those crystals through the funnel into the boiling flask. And someone in the comment, don't remember your name, sorry, I will look through the comments and try to give you proper credit in a caption down here. Somebody suggested, well, why don't you just melt those crystals first and then pour them into the flask? And I'm like, doy, yeah, what a great idea. So I'm going to melt these down and then pour the resulting blue liquid into the boiling flask over there. Should be easy peasy, quick and easy. Alright, so I've got this on this hot plate. It's on high. Hopefully it won't take too long to melt and we can get underway here. Okay, melting this stuff seemed like a good idea, but I'll tell you what, I'm having a heck of a time getting it to melt, all of it. I've got another beaker over the top of it kind of to keep the heat in, and it looks like it's all melted. In fact, it looks like there might be. I don't know if we're starting to see orange fumes coming out of it. So it has definitely been on there long enough. I guess that's mostly just steam. Alright, so it's all melted. It's not sticking to the side of the beaker. That's good. I've got the heat on the boiling flask already because I've got a feeling this stuff's going to want to congeal as I pour it in. So, of course, this hasn't been on for very long, so I don't know how warm it really is. Got leather gloves on over over my other gloves because this stuff is really hot and I'm sure it would love to stick to my skin and burn me really bad like napalm if I got it on me. Oh yeah, even through the gloves the heat's coming through. Okay, looks like we might have gotten most of it out of the beaker. Okay, good. I was worried that there was going to be a lot of it sticking in the beaker and that was going to throw off any yield calculations. Alright, so everything's put together, everything's tight. So we just got to wait for this to heat up. You see, look at the crystals have congealed as they ran down the inside of the boiling flask there. That's what I was afraid was going to happen. But that's okay. This thing's heating up. It'll get plenty hot soon. And hopefully we'll start producing some... well, first off, we'll boil off water, like last time. The first fraction to come over will be mostly water. Then once we start getting a lot of orange fumes, nitrogen dioxide fumes, I will swap out the receivers. And we'll start getting some fairly potent nitric acid out of this stuff. Okay, so I need to get some aluminum foil and wrap this up because it needs to be kept really, really hot. Got my stainless steel Keck clips on everything, so don't have to worry about melting them. I'll get the condenser going shortly when we start getting some steam coming over and there's something to condense. Alright, I thought I'd give you one last look at the setup just before I wrap the boiling flask and the upper part of the tubing here in aluminum foil to keep the heat in. So we've got my hot plate stir plate, which is right now just in heat mode, beast heat mode, because I need this to get really, really hot. And I need to keep the heat in, which is why I'm going to wrap it all in aluminum foil. I've got the boiling flask in a casserole dish. I've got sand around it to help conduct the heat in, since it's a round bottom flask. Got this port here where I introduced the reactants. The other port goes up to the thermometer adapter and then over to the side to the condenser. Got my stainless steel Keck clips on everything. Got Teflon tape on all the joints. There's the condenser. I just primed it with cold water, but it's not running at the moment. There's the receiving arm, the receiving flask, lab jack to get the flask at the right height. First fraction we'll get will be mostly water. Once we start getting a lot of nitric acid and nitrogen dioxide gas, I'll switch this out for that beaker back there, or that flask back there, which I'll be able to get a good seal on, the ground glass joint there, which has some Teflon tape on it. This hose will take nitrogen dioxide gas being produced over to this first flask, which has a couple hundred milliliters of hydrogen peroxide in the bottom of it. It's just store-bought 3%, and it's kind of old, so it may not be a full 3% anymore. It's what I had on hand. And I will dump the first water to come through into this flask too, because that will be a weak nitric acid. Nitrogen dioxide gas is going to have to come through here. A lot of it will dissolve in that liquid and we'll get nitric acid that way. Overflow nitrogen dioxide is going to come around through this hose into the fume hood. And I've got a, I've got a graduated cylinder in an ice bath. Graduated cylinder has more 3% hydrogen peroxide in it. If everything is sealed up good enough, there should be enough pressure to push the nitrogen dioxide gas all the way down to the bottom of the cylinder and have it bubble up out. And hopefully we'll get some more nitric acid in there. And I will turn on the fume hood to exhaust the fumes once that starts happening so that I don't have to breathe them. And hopefully everything will be nice and sealed up this time and we will get some nice nitric acid here and some over here and some in here. And we won't waste all of the nitrogen dioxide. Of course, you know, we gotta wait and see if my changes accomplished anything. Okay, I'm gonna wrap this with aluminum foil to keep the heat in. So let me get that done. All right, got the aluminum foil tent on it. Just waiting for things to get hot enough for something to start happening. Probably take at least a few more minutes before we even start getting any large amount of steam coming over. Be back. Okay, I don't know how well that's showing up in there, but it's starting to boil. It's been quite a little while. It's taken quite a while to get that hot. Maybe because we got a larger mass of material in there. Didn't really measure it the last time, but it took quite a while to heat up to the point where it's boiling. So probably I need to turn on the condenser and start condensing the steam coming off of that. And yeah, we're on our way finally. Yeah, in fact, we're starting to get drips over here. Even though I haven't had the condenser running, we're starting to get drips over here in the receiver. So yeah, the first water's accumulating. Okay, let me get the tent back tight around this so it can stay hot and continue cooking. And hopefully we will get through the boiling stage and start producing some nitric acid here shortly. Yeah, I see, now that the condenser's running, I see water running down it. Okay, good deal. We're on our way. The water's coming over slowly. Pulses of it coming out of the condenser. Not seeing any orange-brown fumes yet. Don't think we're making any nitrogen dioxide yet. Just getting water over. Still got water coming through, but let me zoom out a little bit. I don't know if it's showing up. Got a tinge of orange up here in this arm of the glassware. So it's just about time to swap out the flasks. Give it a few more minutes, and then I will do that. Okay, it's been a few more minutes. I don't know if I'm a little early on this or not, but I am going to switch out these flasks. I think I was late doing it last time. And notice I have switched from nitrile to vinyl gloves. I have videos of my homemade nitric acid setting nitrile gloves on fire. Now I don't know if we're going to be making anything that strong here today. Maybe, maybe not. We could test it. But just in case, I have switched. Now I'm going to pour this liquid into this first flask, aka the suckback preventer. I'm going to add it to that liquid in there, which is hydrogen peroxide. So now hopefully the system is sealed. And you can see the nitrogen dioxide gas filling this flask over here. Hopefully it will come through here, fill this flask, and then continue on into the fume hood and into the graduated cylinder in there. And we will get nitric acid in there as well. So I am hoping that what's coming over now is going to be reasonably strong nitric acid. And not just mostly water. It's really hard to tell when to switch though. I just kind of wait until the fumes start getting heavy. Sometimes I'm a little early, sometimes I'm a little late. Okay, so we'll just let this go for a while and see how it develops. Okay, we've got a pretty good flow of liquid into this beaker. I'm pretty sure we're getting nitric acid, okay? We've got some nitrogen dioxide fumes here, but not a whole lot. They're pushing through slowly through this tube. I can see the color in it, but they're not really filling this flask over here yet. So I think we're not going to see a whole lot of nitrogen dioxide gas coming out until after we're done distilling off the nitric acid here. And then we should start seeing a good pressure of nitrogen dioxide coming out. It should fill up this flask and it should be making it into the fume hood, into this graduated cylinder in there. I think we're basically just slowly pushing air out of the system right now. But that's okay. That just tells me the system is sealed. It's sealed. That's what I was aiming for. Okay. Starting to see a very slight tinge of orange over here. Very, very slight. But, yeah, we haven't reached the end game is when we start producing a whole lot of nitrogen dioxide gas, less and less nitric acid, and the dioxide is going to come flooding out of there and should flood the rest of the system, and then hopefully we'll still get some dilute nitric acid made in the flask and in the graduated cylinder too. Just gotta wait. It's taken a while, and I think we just have a larger mass of material in the boiling flask than we did last time in my little proof of concept test. So, but that's okay. I think we're gonna get more nitric acid out of it. All right, it's a waiting game now. I don't know how well that's showing up, but it's kind of like it's blowing smoke rings of nitrogen dioxide as the puffs of it come into there. Very cool. I suspect we're probably starting to get some nitrogen dioxide through this hose back into the bubbler in the fume hood now. I see a little tinge of yellow in the hose. There's actually less in here than I was expecting. Now I suspect it's going right into solution down here in the liquid, because it's really not building up in the flask the way I would expect, the way it's coming in. So that's okay, I'll take it. Even though I don't have this cooled on ice like I do the stuff in the fume hood, I wouldn't be surprised if a fair amount of it is going into solution, because we're just not getting a buildup in the flask like we are over here. Look how dark that is. So that nitrogen dioxide's got to be going somewhere. I guess it's going into solution, which I will take. And we are bubbling pretty good over here. I really don't see a lot of nitrogen dioxide coming through yet, but I'm starting to see a little bit of a yellow tinge in the hose coming in. So I think I'm going to go ahead and turn the fume hood on, just to conduct any fumes that are coming out away from me, so I don't wind up getting a whiff of them, because for a change I've got the system all sealed up and I don't have to worry about getting a whiff of nitrogen dioxide. I've got a fume blowing at my back as usual, but I'm not sure it's really necessary today because everything's so nice and sealed up. There are no leaks in the system. Everything's just working. All right. Gotta let it go. I'm impatient for a result, but the stuff in the boiling flask doesn't care about my impatience. It'll be done when it's done. Well, it's kind of hard to see as dark as the interior of the flask has gotten with the nitrogen dioxide gas, but the liquid's still dripping at a fairly good rate. This flask is filling up with the gas. So yeah, we must be reaching the end game with the stuff in the boiling flask. Let's take a quick peek in there if we can see anything. It'll probably be so opaque. Yeah, nothing. So full of nitrogen dioxide it's practically black. Okay, what's the temperature in there? About 170 C. Wow, okay. So I would say we're definitely decomposing any copper nitrate in there, any other nitrates in there. We're producing a whole lot of nitrogen dioxide gas. It's actually coming over into the fume hood in there. Yeah, I can see the hose into the fume hood. I don't know if it's going to show up. It's got a tinge of orange to it all the way over. So, alright. So we kind of reached the end game, but the end game goes on for a while. That stuff in there is going to keep producing nitrogen dioxide for quite a while. You know, if last time is any indication, it took a long time before it stopped. Actually, I think I aborted it early because the system was leaking so bad I was just losing it. So I shut things down early. So I don't know how long it's going to run. This could go on for another hour, 2 hours. We'll see. But that's okay. It'll turn the liquid in this beaker into a dilute nitric acid, and it'll turn the liquid in the fume hood into a dilute nitric acid. So we'll just let it continue. See how long it takes. Okay, here's an interesting phenomenon, and it makes me think maybe I should have cooled this. This flask is getting quite hot, which is interesting because the hose isn't hot. This arm up here is cold. This flask isn't hot. So it's got to be, I guess, the reaction of the nitrogen dioxide gas with the water and hydrogen peroxide in here that's causing the heat. So yeah, maybe I should have cooled that too. I wonder if it's too late. We'll put a little ice around it. Get some out of the cooler down here. Cool it down some. Maybe the gas will absorb into the liquid even better. Gas tends to have a higher solubility in cold liquids than warm ones, so we'll just cool that flask down. That's amazing how hot that got. I hadn't noticed how hot it was getting. Okay, maybe we'll get a stronger nitric acid out of that now. And we're still bubbling away in here. The bubbles don't seem to have any orange color to them, but you know, I can see the gas in the hose coming in has a bit of an orange tint to it. So it's got to be some nitrogen dioxide in those bubbles. Don't think it's all staying in that flask over there. Yeah, I can actually see that the hose has turned orange, so there's some gas making it through. Okay, so here's an interesting phenomenon. Ever since I put the ice around that flask over there, I've started getting a lot fewer bubbles in here, which leads me to believe that the nitrogen dioxide isn't making it beyond that flask, it's dissolving in the liquid in there. Okay. So yeah, here comes some bubbles, but they're a lot less frequent. Yeah, I guess that warm as that flask was getting, it was no longer absorbing a lot of the nitrogen dioxide into the liquid there. But now that I cooled it off, it's absorbing it again, and it's just not making it this far for the most part. Okay. Well, this won't be as strong, but that'll be stronger. So, you know, 6 of one, half a dozen of the other. Okay, we've reached the point where there's not many more drops coming down into the receiver flask. So we've boiled off pretty much all of the nitric acid in the boiling flask. So here comes a few more drops after I say that, but they're not coming near as fast as they were. But we're getting a lot of nitrogen dioxide gas. Probably not going to show up because of the condensation on this flask, but I can see a solid stream of it coming in and hitting the liquid there and just disappearing. I mean, it's not filling up the flask with near the fumes that we've got over here, and we got really little to no bubbling going on in the fume hood. So the nitrogen dioxide's coming in. I can see it coming in. It's just not making it out of here. It's getting dissolved in the liquid in here. And that started after I iced this up. Yeah, it's cold down here, but I'll tell you what, it's hot near the top of this flask. Nitrogen dioxide reacting with the condensation in there, maybe at the top of the flask, I don't know, making heat. So, well, we're turning this liquid in here, of which there's probably 200, 250 milliliters. We're turning into some kind of nitric acid anyway. Not sure we're getting much of anything in the fume hood though. But anyway, this setup's going to keep producing gas for quite a while, I'm sure. Maybe the next hour or so. We'll see. Plus we still get the occasional drop of nitric acid coming over. Okay, this has been going on for about an hour now. Really, I'm not seeing any more drips into the nitric acid bottle over here. I am still seeing a stream of gas. Again, it's hard to see with all the condensation on the flask, but I am still seeing a stream of gas coming into the flask. But of course, it's not going anywhere else. No bubbling at all at the graduated cylinder in the fume hood. In fact, there hasn't been any bubbling in there for quite a while. So it looks like all the nitrogen dioxide going into this flask is getting absorbed into the liquid. The stream is not as strong as it was. I think we've probably pretty much stopped making gas, or at least dramatically slowed down the rate at which it's being made. Oh, it's hot in there. Wow. Yeah. Although the temperature is down. It's about 140 C. It was up to about 170 at one point, so I guess that's an indication that there's less material boiling off and making it up to where the thermometer is to condense and reflux up there, so it's not transporting the heat as efficiently. Oh, the inside of that boiling flask is kind of dirty looking. Okay, it's getting very late. I wish I'd started this a little earlier. If I'd known it was going to take this long. I'm going to let this go for just a little while longer, because every time I think it's done, we get some more nitric acid coming over. I'm starting to think that the hose has been damaged here. Yeah, the hose is sweating something. I don't have my gloves on. It's oily. Okay. So this is silicone hose. I don't know what it is sweating. I don't know what the nitrogen dioxide gas is doing to it. But it may be one use. I don't know. You have to find a different kind of hose. Yeah, I don't know what it's sweating. It's not cold enough to be condensing anything out of the air. I don't think. But yes, we've definitely about reached the end here, I think. I'll probably be shutting it off here shortly. Okay, I think it's time to call it and shut everything down. I'm not really seeing any more drips come across. Well, every once in a great while. I'm not really seeing any more gas coming into this flask. It's starting to clear out. So I think we are done. So I'm going to turn the heat off, let things start cooling off. Take the foil off. And yeah, that is hot, let me tell you. And it's full of nitrogen dioxide gas. I'm thinking, oh, it boiled pretty hard. I see blue stuff all the way up here. I wouldn't be surprised if we got some contamination in the acid down here. That's okay, I'm not too worried about it. I'm thinking in the future, I may need to produce some sort of rig that will blow a little trickle of air into the boiling flask to clear all of the nitrogen dioxide out. Just push it through the system all the way out. Because being heavier than air, it doesn't really want to dissipate. It just wants to hang out there. Okay. So yeah, ooh, I see some blue in here. So yes, we do have some contamination. Okay. It boiled kind of hard. Alright, not too worried about it. I guess even Nerd Rage's nitric acid was a little bit blue, so. Alright. So we'll just let this all cool down for a while. It's just too crazy hot to touch. And we'll be back and see what we got. Okay, things have been off for a while. Starting to cool down over here. The system is still just full of nitrogen dioxide gas, though it is not going anywhere. So I'm going to try an experiment, another experiment, an experiment within an experiment. I've got fish tank bubbler here, plugged in. It's putting out a little puff of air here. So what I think I'm going to do is I'm just going to feed the air in through this side arm and see if we can blow the nitrogen dioxide throughout the system. Uh-oh. Yeah, okay. This hose is not long for the world, obviously. It doesn't handle the nitrogen dioxide well. Okay. Woof. Came apart on me. Okay, but yeah. Okay, so it's coming back in over here. Yeah. Yeah, so we got nitrogen dioxide coming back in over here, so that's good. Probably start bubbling in here pretty soon. Maybe, I don't know, maybe it'll all just dissolve in the liquid there. I mean, there's not much air coming through, so this is probably going to take a little while. But, yeah. It took forever for the nitrogen dioxide to diffuse out of this stuff last time, so I'm hoping it goes a little quicker this time with just puffing a little air in there. We'll see. We'll see what time it is. We'll see how long it takes to clear out. Okay, it's about 10 to 5. Okay, well that only took about 10 minutes to clear all of the nitrogen dioxide out of the boiling flask. It's going up system, and it's starting to clear out that flask. It's going back through that flask. We got bubbling in the fume hood again. So, okay. All right. And then, you know, we can see into the boiling flask now. We can see what we got in there. That dark blue, green, black material in there is copper oxide. We cooked the heck out of this stuff this time. It's all converted into copper oxide. It's quite a crust of it inside the boiling flask, and although it looks like the flask is ruined, it's not. What I found out last time with my proof of concept test was that I can put some water in here and some sulfuric acid and put a stir bar in, turn on stirring, and what's going to happen is that nasty looking stuff in there is going to get converted into copper sulfate. It's all going to go into solution, and I'll be able to pour it right out of the flask. The flask will be as clean as it was the day it came out of the factory. It's going to be a beautiful thing. Plus, I've created another useful reagent here out of my waste product. I can use the copper sulfate that's going to be created here as electrolyte in my copper refining cell. So I will, when I pour it out of this flask, I will keep it and I'll crystallize it and I'll save it for that. Okay, and yeah. Nitrogen dioxide is moving down system, and pretty soon the whole thing's going to be cleared out. Now it's getting pretty late in the day, though. I may have to save cleaning up for tomorrow. Cleaning up and trying to figure out what the strength of the acids I made here are. Yeah, that may have to wait till tomorrow. But I do want to find out if I've actually made any acid in the fume hood. I mean, we've got some pretty vigorous bubbling going on right now because we're pushing everything through the system. So we should be making some acid in there. Okay, let's see about this stuff in the fume hood here. Oh, well, yeah, okay. Yeah, look at the color. Yeah. So we got some dilute nitric acid in there, and it's bubbling away as the system pushes air through. So yeah. Oh, you know what? We had a little bit of suck back. There's liquid in the line. Okay, see, that's what that flask is meant to do. It's meant to prevent liquid from being sucked back into that flask. So it did its job. Yeah, we got a little bit of suck back after I turned the system off and before I put the air in over there. So, okay. So, that worked. Alright. and we got acid in there. So, all right, cool. Okay, this has cooled off enough that I think I can put some water in it without risking a steam explosion. Gonna put a stir bar in it too. Put some water in. Okay, get that stirring. And then we're going to put some concentrated sulfuric acid in there and magically turn that blackish muck into something that's going to dissolve. Pretty easily. Oh yeah, water's already starting to turn blue. Okay, I think I'll put a little heat on it too, just to speed the process up. It may need some more acid before I'm done. I don't know if that's enough to dissolve all that copper oxide in there, but we're on our way. And we've got a pretty good amount of fuming nitric acid here. That's probably pretty strong stuff. And we've got a pretty good amount of some dilute nitric acid over here that I would imagine is probably pretty potent. And we've got some in the fume hood over here in that graduated cylinder. Although I think the graduated cylinder burped up over the top a little bit. I shouldn't fill it up so high. So we lost maybe a third of the liquid into the ice bath. So note to self, next time, do not fill it up so high. Okay. Couple of things before I call it a night out here. I did a quick and dirty test. A few drops of this highly concentrated acid on a nitrile glove, and it did not burst into flames, although it did eat it up pretty bad. So it's not the strongest acid I've ever made. I may have actually switched the beakers out too soon and got some water in here, but it is pretty darn potent. I mean, it's doing a number. It's eating that nitrile up. It just didn't burst into flames. So okay, so this is probably stronger than the azeotrope of 68-70%, but it is not like the 95+% that I make when I use fully dry ingredients. So still pretty potent acid. Okay guys, it's like an hour and a half, 2 hours later. It's after dinner. It's starting to get dark, but I need to clean up this mess and put everything away because we're going to have some rough weather tonight and for the next day or two. So I'm not going to be able to get back out here. I just thought I'd show you that big slug of black stuff in the bottom has all dissolved. So we've got copper sulfate solution there. So I will transfer that to another beaker and let it evaporate down and crystallize, because I could use the copper sulfate crystals. Over here are the 3 strengths of nitric acid that we have produced. Now I already tested this, so I already did a quick and dirty test on this on a nitrile glove, and although it didn't catch fire, there was a pretty strong reaction and it chewed holes in it, so it's pretty potent. We'll do a more thorough test on this probably another day, but I would like to know what the relative strengths of these 2 acids are. So I've got a couple of little test tubes here. I'm going to put a strip of copper in each one. I hope I'm doing this on camera. Can't see the viewfinder. Alright, so we got copper in each one. We're going to put a little bit of these acids into these test tubes and see what happens. So a little bit of this stuff first. I got a feeling this is going to be the weakest stuff I got. Yeah, it turned the litmus paper red, but how's it going to react with some copper? Well, I'll tell you what, that is some shiny copper now, and it's bubbling. There's some bubbling going on. Not super furious, but it's bubbling. Alright. So that's starting to dissolve the copper. In fact, I don't really see any color yet. Thought I did, but I don't. Alright, so let's get some of this stuff, which I think is going to be quite a bit stronger. We'll see if I'm right. Well, actually, there's hardly anything going on in there. Again, the copper got nice and shiny, but that's about it. I am surprised. I am very surprised. This has got a very vigorous reaction going on. And the liquid is starting to turn a little blue. This really is a little bit of bubbling. I am very surprised by that result. I would not have thought that this was stronger acid than this. I thought it would have been just the other way around. Maybe it's because the gas was bubbled through here. I don't know. But wow. Yeah. That is just going gangbusters. And this is doing not much at all. Little bit of bubbling. Okay. Let me try a little bit of this stuff in a test tube with some copper all by itself. Okay, I got another test tube here. You get a little bit more of this stuff. Wow. Holy moly. Yeah. Okay. That is some potent acid. Okay. So, when the weather clears up a little bit, in another day or two, we'll try and figure out what the actual strength of this stuff is, okay? You know what, I had a thought. I wonder if all that bubbling's from the hydrogen peroxide more than from the nitric acid, because even though there's a lot of bubbling going on from this stuff, the liquid really has barely turned blue. So, maybe that's just hydrogen peroxide. Maybe we'll do one more test before I shut down for the night. Let me get another test tube and some hydrogen peroxide, and we'll see what happens if I throw a copper strip in there. Okay, we got a little bit of a control test here. Got some copper in this test tube, a little bit of hydrogen peroxide. Same bottle of hydrogen peroxide I used in this test to fill these up. Just a little bit left. And I'll tell you what, there's absolutely nothing going on in there. So the bubbling from when I put this stuff on the copper wasn't from the hydrogen peroxide. This stuff is actually a fairly decent nitric acid. Dilute, but decent. It's still bubbling away in there. And the water's turning blue. So that works. There's nothing going on here. Okay. So this is a halfway decent dilute nitric acid. This doesn't seem to have any activity to it at all. And I'll tell you what, it's gone cloudy too. And you know what? I'll bet I know where the cloudiness came from. I'll bet it came from this hose. Because this hose, or maybe from the stopper. Because the stopper is discolored and the hose is falling apart. The hose has no strength left to it. Yeah, the hose, this is silicone hose. Obviously, it could not handle nitrogen dioxide. So, anybody out there got an idea what kind of hose I should be using for this that won't fall apart after one use? Okay. The stopper's gone sticky. And it's, yeah, coming off. So, again, you know, if anybody out there knows what kind of stoppers I should be using, let me know. So this stuff here, I guess is just, I need to dump into my acid waste bucket. So I'm sure it's got a little bit of acid in it, but it's certainly not good nitric acid. This is better, and this is best. That's nothing. Okay. Maybe when the weather gets a little nicer, in a day or two, we'll see if we can figure out the actual percentage of nitric acid we have here. I think it's pretty high from the tests I've done on it. Probably stronger than the azeotrope, but not quite as strong as the nearly pure acid I make when I use dry chemicals. So, alright, we'll see if we can figure that out in a day or two. I got a mess to clean up.